parsing the HTML until that JavaScript's been executed, and that delays the initial page load. You should also avoid linking to JavaScript in the head of your HTML page for very similar reasons. In this case, what will happen is, particularly in some of these older browsers, when it encounters this script tag, it's going to go download the script file and execute it before it will continue parsing. The best practice is to link the JavaScript at the end of the file. This allows the browser to fully parse the HTML document, to download all of the images, and the images will be displayed to the user first, so they can be progressively rendered to the user and make your sites appear more quickly. And then the browser will download the JavaScript and execute it last. Now, there's some cases where you really must include your JavaScript in the head. Cases such as content management systems, if you're using some server-side frameworks, those frameworks may place your JavaScript in the head itself. In those cases where you must have it there, we recommend using the defer tag as a best practice. The defer tag has actually been supported since Internet Explorer 4. And what the defer tag does is it defers execution of the JavaScript until the page has been rendered and laid out displayed to the user. I do not know if Firefox supports this yet. So the third subsystem that really comes into play is the CSS parsing subsystem. As the HTML parser encounters CSS, it's handed over to the CSS parser. And there's a couple of really important best practices here that are very similar to the JavaScript best practices. And the first is to avoid embedded styles. This is less important in Internet Explorer 8 and some of the modern browsers. But this pattern can significantly slow down the performance of loading web pages, again, in some older browsers. But counter to linking JavaScript at the end of the file, the best practices here is actually to avoid linking your CSS at the bottom of the file, and instead to link the CSS at the head. What this does is it allows the browser to download the CSS immediately so that it has all the style information, and that style information can then be applied with the HTML and displayed to the user. Sometimes if the CSS is too low in a page, what will happen is you'll end up with a flash of what we call flash of unstyled content, where the web page will appear. It might appear with the right text, but it's not the right font, not the right colors, not the right locations. So include your CSS files at the top. And also, best practice is to avoid using the @ import for hierarchical styles. This is actually an external style sheet here. And at the top of the external style sheet, it includes, you can see, links to two external style sheets. Particularly in some older browsers that are still very common on the internet, what will happen here is when the CSS parsing is occurring, it'll hit the @ import, and it will have to go download first the style sheet 1 and then second style sheet 2 so that it can create the hierarchical cascade associated with them before it can finish parsing this CSS. For scenarios where you'd like to create hierarchical styles, we recommend multiple style sheets, again linked at the head of your HTML. The next browser subsystem is what we call the collection subsystem. I'm not going to recommend any best practices here today, because if we go back to our pie charts, it was the smallest slice of pie. But really, collections is, you think of it as a collection of attributes associated with your HTML elements. I'd like to move on to JavaScript, because there's a lot that you can do in your JavaScript code today to just improve performance. And the first and probably the most important best practices is to minimize symbol resolution. Symbol resolution is what a dynamic language runtime or a JavaScript engine does to map a symbol, such as in this case the variable foo, with the actual value of foo. And the way that JavaScript runtimes do this mapping is they work their way through a scope hierarchy. They'll start in the local scope being really where the script is currently, where the script is running. They'll work their way up through the intermediary scopes, and then finally, they'll go to the global scope if they're unable to find it lower and resolve that variable in the global scope. The further away that resolution is from where it's used, the higher the cost. Now, I'll show you some examples of this in a minute. This is true for variables, but it's also true for members or instances. In this case, I have an object with a foo member hanging off of it. It's first going to look in the instance of that object. It's then going to work its way up the prototype chain. And then finally, it's going to have to cross over into the document object model if it's unable to find it in the chain. And in some cases, may actually need to create it. Now, let's take a couple of look at two different examples on how to minimize symbol resolution. You can see that I have a function here with a local variable set to 5. And then my return statement is just going to take my local variable and add 1. You can see that my local variable, I didn't actually specify the var keyword. And so what happens in this case is it has to walk all the way up to the global scope to find that local variable. So even though I'm only using it in this function, it's actually a global variable. By adding the var keyword, I've then scoped it to local. This is a very common mistake that's made across many different websites, web properties today, even among sophisticated JavaScript developers. The next best practice, which is very closely related, is minimizing symbol resolution for functions. In this case, I have a worker function, and I'm iterating over a collection of items. And each time I call the function work, it has to resolve where that function is located. In this case, it's walking up that chain to find the function work. What I could do is I could create a function pointer. So I've created a local variable called funcWork, and I've set it to the function work itself. And then when I call that function, I'm actually referring to that local function pointer, and it increases the overall performance of this loop, in some cases quite significantly. The next best practice is to use native methods, in this case, particularly for JSON. How many of you use JSON today? How many of you use JSON by calling eval on your JSON when it's returned? Good. I only saw one hand there. Maybe it was a half of a hand. How many of you use a JavaScript framework to actually parse the JSON object when it's returned? Almost everyone. So the JavaScript frameworks are a very effective technique for using JSON. But what that means is that the JSON serialization and deserialization is occurring in script through script objects. By using the native JSON methods, which were first introduced into Internet Explorer 8, to do your serialization and deserialization, you can actually improve performance of this by some cases 5 or 6, a multiple of 5 or 6 times. And kind of finally, the last best practice for JavaScript is to remove duplicate script files. People often laugh when they hear this one. In this case, you'll see that we actually have 2 duplicate jQueries in the bottom. This is sometimes just a common mistake that people made accidentally. Sometimes people come across this and they don't realize there's a performance implication, so they don't address it. Sometimes it's the frameworks that you're using on the server as they compose components together